This is the first one we're going to look at. This was a bad bearing that was identified. It's on a combining roll. So these are conveyor bearings where it's moving product along from one part of the facility to another. Various different processes are involved. And if any of these bearings fail, it kind of brings the whole thing to a grinding halt. So they're taken data and established sort of a baseline and put in an alarm based on the RMS. And they had seen an increase in the noise on the bearing. So they continue to monitor it over the next couple of months. So going out there on a regular basis, taking more data, and they could see that things were definitely getting bad. You can see from the trend here, it was relatively stable and then kind of jumped up and remained up there. So even after greasing, didn't have a lot of effect. You can see in the time domain here, indication of impacting that's going on. And from my static readings here, you know, we jumped up from normal being down around 4 or 5 dBs up into the 20-25 dB range. Huge increases in our peaks and therefore our crest factors. So the repetitive impacting could be heard in the time waveform, and that huge increase in the crest factor prompted a work order to replace the bearing. So let's see what it sounds like. Is that coming through okay? Can everyone hear that?
Yeah, it sounded like a horse walking to me.
Yeah, it's like a clippity clop, but repetitive impacting going on. So once they actually took this apart, there was a lot of looseness in the cage, and there was some definite damage on a number of the rolling elements, but this one was definitely the worst. So kind of pick this one up as a good example. So every time that rolling element is moving around, it's causing an impact in the raceway, as you can clearly see in the time waveform. So a good win. They were able to get it changed out before it stopped the process. So